In this section, we're going to explore a number of considerations that are important when designing applications in the cloud. The first category of conversation we're going to have is around operational excellence. And operational excellence is important because it enables us to deliver higher value with lower effort. So let's take a look at what's important in terms of enabling us to be able to achieve those outcomes. In the cloud, it's very important for us to create an environment that enables agility. In other words, enables us to deliver more with less at much faster pace than what's previously possible. And doing this requires us to make available tools that developers can use that accelerate the pace of development. Typically, we talk about things like continuous integration and continuous delivery. We talk about GitOps. We talk about SRE. These are all practices which are designed to enable organizations to accelerate the pace at which they innovate. So very important when assessing the capabilities of cloud providers to look into the tools that they make available to support agility. In addition to agility, also important for us to have visibility of the environment, for us to not only be able to perform forensic analysis when things go wrong and we need to figure out what happened, but also for us to be able to take action. So the ability to monitor resources on the cloud, the ability to generate alerts that are actionable, the ability for us to aggregate logs that enable us to configure potentially custom alerts that may be more in line with the nature of our application. All of these types of capabilities are very important in enabling us to have a view of the end-to-end health of our application. When planning for and designing for failures, it may be worth considering the locations where cloud providers have a presence, the level of investment, because all of this could have an impact in terms of providing you or making accessible to you the infrastructure that's required for you to achieve the level of fault tolerance that is desired within specific regions around the world. Having explored operational excellence, we're now going to move on and have a look at security, privacy, and compliance. The cloud potentially exposes us to additional risks, so we need to be mindful of what those risks are and take the relevant precautions. One of the considerations that need to be made is an assessment of the suitability of authentication and authorization capabilities in the cloud. There are cloud providers that will provide mechanisms where users can authenticate to systems in the cloud securely without necessarily having to create a virtual private network that connects the on-premises device with the cloud network. And these identity-aware proxies can significantly simplify security configuration. Compute services may also have additional controls that are required. For example, you may want to deploy virtual machines, but not assign public IP addresses to those virtual machines. But those virtual machines may need to be administered by users who are accessing the virtual machines from outside of the cloud environment. So once more, you could use identity-aware proxies in order to facilitate those types of connections securely. You may also have virtual machines that need to be updated, but without the need for provisioning public IP addresses. So you could use a network address translation service in order to achieve that. And there are many, many more capabilities that allows one to secure workloads or secure virtual machines in the cloud while enabling the level of access that's necessary from outside of the cloud network. Data services also typically require specific controls. For example, when storing data at rest, there may be a consideration that has to be made with respect to encryption. Do you, for example, encrypt data using keys that are stored in the cloud and managed, for example, using a key management service? Or is it a no-no? Do you have to retain those keys outside of the cloud environment and provide the keys as and when required for encryption purposes. And you may also want to consider upfront the lifecycle management of access control policies. From a network security controls perspective, there are many mechanisms that are available in the cloud to create isolated networks. And these isolated networks can also be connected to other networks. For example, in most clouds, you have the ability to peer networks. Networks in the cloud can be integrated with on-premises networks. So once more, you've got to consider the implications of essentially integrating networks. You may also want to consider controls that you can leverage within the context of networks. For example, firewall rules and routes that gives you the ability to control traffic flowing within networks. And from an application supply chain perspective, there are a range of capabilities that we can apply from the point where an application is being developed. For example, the ability to analyze container images that are built from source code, the ability to scan source code for vulnerabilities. Once container images have been scanned and uploaded into a container registry, there may be capabilities built into the container registry to further scan the image. You could also use cryptography to digitally sign images, thereby assigning a seal of approval, indicating that the image has been through the relevant due diligence in terms of the supply chain. And once images are running in a production environment, there are additional capabilities that you can leverage in order to secure access to those images. For example, you could deploy workloads into sandbox environments that keep the workloads isolated. And as we all know, we do make mistakes. So the ability to capture system events and admin activity logs is very important. The ability to analyze those logs and take preventive measures, equally important. And also making sure that the audit logs are retained for as long as necessary in order to safeguard the integrity of the system. Service reliability is an important consideration. So here we're going to look at some of the capabilities that we need to consider in order to design for reliability. For example, some cloud platforms will provide you with tools that enable you to specify goals, service level objectives, which are based on specific service level indicators. And these tools will enable you to measure compliance with those objectives. And you can also configure alerts which notify you when you are likely to breach the relevant levels that you seek to attain. It is therefore very important for you to consider the capabilities that are available from the cloud provider to enable you to embrace practices such as site reliability engineering or DevOps, right? Capabilities that enable you to deliver a quality service to your end user. Integrated observability is a very important consideration, particularly where deploying workloads within a hybrid environment. Generally speaking, most cloud platforms have proprietary tools for monitoring, logging, and error reporting, etc. So having a level of consistency or having an end-to-end view across multiple clouds can be quite challenging. There are nevertheless capabilities that we can leverage that allow us to gather metrics at a level which is agnostic of the underlying cloud platform. Scale and high availability is another important consideration. It's very important to carefully consider the locations where service providers have physical infrastructure, and also to remember that services may not necessarily be available in all of those locations. So if there's a service that is of particular interest that you need to access in a specific region, very important for you to make sure that service is currently available within that region to the level of scale that your business may require. It is also important to think about automation. GitOps comes to mind, the ability to manage infrastructure as code, the ability to create pipelines that are flexible, the ability to integrate open source CI/CD tools within your infrastructure. Automation not only enables better performance and agility, it also significantly reduces errors. And when errors do occur, automation makes it a lot easier for the root cause of those errors to be identified and for the errors to be fixed. So we cannot overemphasize the importance of automation in the cloud. And when considering automation, it is also important to think about monitoring and alerting. And generally speaking, the incident management process should be collaborative, blameless, and designed specifically to identify issues and prevent those issues from reoccurring. In this final section, we're going to discuss performance and cost optimization. Autoscaling is very important because it enables us to align resource allocation to the needs of our application, which hopefully translates to the needs of end users. And as a result, autoscaling typically results in a lot less resource wastage because our resource allocation more closely aligns to the actual resources that are needed by the applications running in the cloud. In addition to autoscaling, it's also important to think about data processing optimization options. There are many tools that are available on the cloud, from data warehousing to tools that allow us to process streaming data. So depending on the velocity or the size of data or the processing requirements, for example, streaming or batch-related processing requirements, there may be particular services that would be more appropriate. The cloud also offers a range of processors, from GPUs for graphics-related workloads and TPUs for machine learning workloads. So depending on the service that's selected, we may have the ability to optimize our cost as well as performance by selecting the appropriate CPU chipset. There are also capabilities such as trace, profiling, and debugging, and these services allow us to have a better view of the performance of our application, identify bottlenecks, and hopefully take action to optimize the performance of our application. And we're going to end with a reminder of something we've mentioned earlier in the previous module. So cost analysis is very important. There are services available on the cloud that provide you with a mechanism for exporting data in a way that allows you to get more fine-grained information on resource usage. And it also enables you to analyze resource usage and convert that information into billing insights. That not only enables you to optimize your spend, but also to allocate services that are more appropriate for your use case. The concepts that we've presented in this module enables us to design applications in the cloud that are efficient, secure, resilient, and cost-effective.